Hello, friends, and welcome to KDL's Grow with the STEM Greenhouse. In this program, you're going to do different STEM activities. There's fun and hands-on experiments that you can do from home. Hosting them is our friend from STEM Greenhouse. She's actually the person that created it. Her name is Dr. Keli Christopher, and a fun fact about her is that she has her PhD in agriculture engineering from the University of Illinois, and she's the first Black person to have that degree from that university and the third Black woman in the whole wide world to have that degree. So join her for some different activities. We're going to be featuring 7 activities this summer for you to do at home. If you need the instructions and you want to print them out so you know what you need to do, and you have some written instructions to follow along, you can access those through our website. If you go to www.kdl.org/KDL-lab, you'll find the instructions there in some of our blog posts. So get excited and get ready to learn about some more STEM things. I'm going to pass it on over to Dr. Keli. Have fun!
Hi, STEM scholars. I'm Dr. Keli Christopher, and I'm so excited to talk to you today about thermal energy. Now, you may not know what thermal energy is, but you might know what thermal means. Perhaps there are other words that you know that sound like thermal. Maybe thermos, thermostat, thermometer. So what do all of these things have in common? Well, they're all related to heat. So what we're going to be talking today is basically about the transfer of heat and thermal energy. For the first activity, you're going to need a balloon and you're going to need some ice cold water. I've got that here. If you don't have a bowl big enough, you can always use a sink and just put cold water in the sink. But first, let me blow up this balloon. That's pretty good. Now, if you're not familiar with tying balloons, you might need a grown-up to help you tie the balloon. Okay. So when I blew up this balloon, I put air particles into the balloon. The air particles that are in this balloon, they can't come out. There's no particles can get in and no air particles can come out. We're going to measure the circumference, or the round outside of this balloon, and see how long that is in inches. So I'm going to take this measuring tape and wrap it around the widest part of the balloon on the outside, and I'm going to take that measurement. Okay, so it's about, I would say 22.5 inches. Yours will be something different. You're going to get a little card and in your STEM kit. So be sure to write the before measurement on the STEM kit. Okay. Now I'm going to put that cold water in the bowl. And like I said, if you don't have a big bowl, just put cold water in a sink. Tap water is fine. Or you can put the water in the refrigerator and get it really cold. Now, for this activity, you're going to have to hold the balloon in the cold water for 3 minutes. In order to time that, you might want to use a phone or a clock or something. I'm going to just use the timer on my phone. So I'm going to get started with that right now. All right, time is up. It was a little difficult holding that under the water, but just put some pressure down so it doesn't float to the top. We're gonna measure the circumference of the balloon again. Whoa, it's a lot slipperier now than it was before. And now, for my balloon, I've measured it, and now the circumference is 2.5 inches around. So what happened there? We took a balloon, it had air in it. We made the air in the balloon cold by putting it in some icy cold water. We know that no air went in, no air got out. So what happened to the particles of air that were in the balloon? The same amount of air particles were in the balloon before and after we cooled the air down. Well, in physics, what really happens is that all those air particles, they start moving slower as the heat is taken away, and they get closer together. This is why a lot of materials actually shrink when they get cold. For example, streets in Michigan in the wintertime, when it gets cold, the streets actually shrink, and that causes cracks in the road, and that's why you see so many potholes in the wintertime in Michigan. Also for sidewalks, you might notice that they actually put lines, little cracks in the sidewalks already so that the sidewalk has space to expand when it gets warm and to shrink down when it gets cold. So that's one thing we're learning about particles and how they move when they get cold. The next activity, we're going to use some cold water and some hot water. Okay, for the next activity, we have 2 cups. And in 1 cup, I'll say on this cup here, we're going to put some cold water. And in the other cup, we're going to put some warm water. Now you can just use cold and warm water from the tap. You don't have to make the water any hotter. In your STEM kit, you will also find yellow and blue food coloring. You'll also find a worksheet in there. So we're going to be taking some observations in this activity. So on your worksheet, we're going to observe what happens when we put, when we put the food coloring in the water, both the cold and the hot water, for a total of 10 minutes. And we're going to write down our observations for every minute, okay? We'll add a couple of blue dyes to each. This is the cold water, this is the hot water. Okay, so one observation from the start might be, oh, it looks kind of streaky. You would write that down. And then you would write the cold water, your observation for that one as well. And again, you get your timer or your watch and just wait a minute and then revisit. So our time is up. What did you observe? Well, we have our hot water and our cold water. You may have noticed that the way that the food coloring mixed in both of these cups was different. In the hot cup, the green color was formed faster because the particles were moving faster. That heat energy, that thermal energy, makes the particles move faster in the water, and you can see how it mixes the food coloring. In the cold water, the particles don't move as fast, and so the color stays separated longer. You might notice the blues kind of stayed at the top for a long time because the particles were not mixing. So basically what we are learning from this is that particle movement is a lot slower when it's cold, and it's a lot faster when it's hot. Well, that's all for today. I hope you learned something, and I hope you had fun. I will see you again next time. Bye.